If you observe this problem, what he is asking range function. So range of a function means set of all y values. Simple definition is set of all y values. Y is nothing but function values. Here you have it is three different function combination. One is fractional part of x, other is cos function, other is step function. Here step of x lies between fractional part of x is nothing but if you say x as 1.2, fractional part of x is 0.2. That is a smaller number which lies between 0 and 1. And regarding cos function is decreasing function. So graphically what we write is here it is when x lies between 0 and 1. Let me write here it as pi by 2 and cos graph cos 0 1, cos 90 0. So here cos x function by default you have to understand as x radians, where x radians is angle, x is a number. So this pi by 2 radians is angle, pi by 2 is a number which is 3.14 by 2, approximately 1.57. 1 will be here. This length of this y is cos 1. So as x increases, cos value is decreasing. That means fractional part of x, which implies cos 0, this one, is more than cos x, fractional part of x, greater than cos 1. So decreasing function, initial value dominates. 1 greater than cos fractional part of x greater than cos 1 in the sense cos 1 radian. If I take reciprocal, because it is in the reciprocal, AB are positive, 1 by A will be less than 1 by B. So here I can write cos fractional part of x is cos 1 radian. Here it is cos 1 radian. Uh, 1 radian is roughly 57.3 degrees, roughly cos 60, which is half. So I can say less than 1 by 1 by 2, which is 2. That means finally the required one, 1 by cos of fractional part of x, uh, which implies integral part. Even you take one between 1 and 2 means 1.5 or 1.6. Definitely integral part will be 1. So the range contains only one element, so that is 1. Right. In this second question, uh, basically domain definition, values of x for which fx is defined. Meaning of defined is f is defined at x equal to a if f of a has value. Value means it can be negative, zero, or positive. So, what I mean to say here is generally we can feel that anything is value. Suppose you take f of x as 1 by x, f of 2 will be 1 by 2, it's a 0.5 or 10 by x, let us take. 10 you divide with 2 to get 10, there is a number 5. F of 0 you take 10 by 0. So 10 you divide with 0 to get 10, there is any number means no number. So such thing is no value. Whenever function has value, that particular x we take in the domain. So here it is a combination of root function. Problem is related to root function, one log function. Both are involved in it. Root is defined for x greater than or equal to 0. Whereas this function, second function, is defined for only x greater than 0. And another information which you require to answer this question, definition of log. Log x to the base a is defined for x greater than 0. Log negative is not defined. A also should be base also condition and a should not be 1. Positive, but it should not be 1. This is a logarithm definition. Now, based on this, uh, here it is, you have a ln. ln means it is log x to the base e. And the here function he given is ln mod x minus 1 of x square plus 4x plus 4. Here you can write it as log x plus 2 whole square mod x minus 1. Here is defined for x plus 2 whole square should be greater than 0 based on this. So it is possible for all values are real number except minus 2. When minus 2 is there, it is 0. Other values, we don't have any trouble. Whether it is negative or positive, square is there, it will be positive always. And on base, it should be greater than 0. That is this condition. Sorry. this condition, base condition, and it should not be 1 also based on this. That means base should not be 2. That means x cannot be either 2 or minus 2. Here it is mod x greater than 1 means x lies between it minus infinity to 1 and 1 to infinity. So from this I can say it is minus infinity to 1 union 1 to infinity except minus 2, sorry, here it is minus 1. So minus 2 and 2. Right. And another, here it is, and it is a root function which is defined. Root function is defined for, that is whatever is inside root mod x minus 1 should be greater than or equal to 0. If it is less than 0, root of negative not defined. This one I can write it as log 1 to the base mod x minus 1. The problem which I chosen is lengthy, but it includes all the properties, definitions. Here, log x to the base a greater than log y to the base a implies x greater than y for a greater than 1, which implies x less than y for 0 less than 0 less than a less than 1. So the base is less than 1, opposite inequality, base greater than 1, same inequality. I took the same base. So as we know, it should be, let us take base is greater than 1. X plus 2 whole square is greater than or equal to 1. Right. Here it is mod x should be greater than 2. X plus 2 whole square minus 1 square is greater than 0. It is x plus 2 minus 1, x plus 2 plus 1. It should be greater than 0. So for this inequality, x should be less than minus 3 or x should be more than minus 1. So the common solution here, x mod x greater than 2 means and it should be less than minus 3 and it should be more than minus 1. So minus, this is minus 2. Here it is minus 1, minus 3. So less than minus 3 is this part, greater than minus 1 is this part. The common part will be uh, minus infinity to minus 3 union to infinity. And the last part here is base lies between 0 and 1, that is this case. So here you have a mod x minus 1 less than 1, x plus 2 whole square instead of greater less. Mod x less than 2 here, x plus 2 minus 1, x plus 2 plus 1, that is less than 0. So x lies between here minus 3 and minus 1. Less means lies in this. Here it is x lies between minus 2 and 2, and it is minus 3 again. So here minus 2 and minus 3 will be somewhere here, minus 1. So the common part is minus 2 to minus 1. So here all the values, if I take, we have one solution we got here. The second solution we got somewhere here. Third solution is this. So combining all these solutions, here it should be minus infinity to, I'll take here, put some box. Here is first solution is minus infinity to minus 1, 1 to infinity. First solution. That minus 2 to exceptional, minus 2. What I say here is I cannot take minus 2, I cannot take 2. And the second solution is, okay, this is first solution, except these values, minus infinity to minus 3. We have to combine these solutions, not intersection. Uh, Minus infinity to minus 3, and other part is 2 to infinity. Second one. And third part here is minus 2 to minus 1. This part. So finally, answer is you can take all the values from minus infinity to minus 3. We don't have any trouble. And here it is 2 to infinity also we can take. Shall we? No, except 2. 2 to infinity, and the last case we got solution is minus 2 to minus 1. So this will be our final answer. In this particular problem, root function definition, log function definition, basic logarithmic inequalities, everything came. It's nothing but doing 5 to 6 problems. And here, this function, it is modulus and root functions. He's asking uh, domain of the function root tan x minus tan x is defined for mod tan x minus tan x is greater than 0. Equal to 0 means 1 by root 0 not defined. So in which case it is possible, suppose you take tan x greater than 0, Mod tan x will be tan x. In this case, 1 by root 0, no value, we are least bothered of that. Tan x is negative, mod tan x will be minus tan x, which implies the function. It is minus tan x, which is 1 by root of minus 2 tan x. So it's tan x is negative means minus 2 tan x will be obviously minus of minus, it will be positive defined. So now tan x is negative means uh, x will be in basically if you take the graph of tan x, then in 0 to pi by 2 it is positive. Minus pi by 2 to 0 it is negative. So that means here x must lie between minus pi by 2 to 0. It is negative. So it is a tan graph is a periodic function with period pi. If I add pi, because every pi process repeats, pi you can add or 2 pi you can add, doesn't matter. So pi if you add it, pi minus pi by 2 less than x less than pi. Or you add n pi to it, it doesn't matter because it's a periodic. So the suitable option is second. Pi or 2 pi plus or 3 pi plus any n pi you can add it. Once you add n pi, you get the second option. Here it is, you have two functions, you have to find domain. We find the domain of first function, we find domain of second function. Mixture domain is intersection. The first function domain is first whatever is inside root that should be greater. X should be less than or equal to 3, but at the same time x should not be 1, 2, 3. So x is 1, denominator is becoming 0. So here less than 3 anyhow 1 to won't be less than 3 means it is minus infinity to 3 except these values. So this will be the domain function. This is our domain. Second function, sine function, you know it. It is domain r from minus 1 to 1. Sine inverse x will be, but it is not r. Its domain is r. For existence of inverse, you should restrict domain to this. So inverse exists only it is a bijective function. To have a bijection, range must be this. So we are not concerned about right now the range. We are interested in domain. This x must lie between minus 1 and 1. So 3x minus 2, whatever here, it is lies between minus 1 and 1. Here another beautiful point is integral part of x is less than 1. Uh, it implies x is less than 2. You understood this, like even 1.5 you take, which will be 1. You cannot take 2, you can go up to 2. From that I can say 3x minus 2 will be less than 2. 3x minus 2 is less than 4. 3x is less than 6. X is less than 2. And now let us come to this point. Step of x is greater than minus 1. So does it imply x greater than minus 1 or anything else I can take? I can't take right side. If I take minus 1.5, it becomes minus 2. Minus 2 cannot be greater than 1. So as it is, I have to take x must be greater than minus 1. So from this 3x minus 2 by 2 is greater than minus 1. 3x minus 2 by 2 must be greater than minus 1. Here it is, we can write 3x is greater than 0, x greater than 0. So now here uh, there are two, it lies in the boundaries between minus 1 and 1 means. So finally, what I got here is from this 0 less than x less than 2. So now, how do we find the domain? Since there are two functions involved, so one is 0 to 2, other is minus infinity, this 0 is included. Where is other? This is our first domain. So minus infinity to minus 3, sorry, plus 3. Except 1 and 2. 1 will be here in between. So that means this is the common part. So actually common part is 0 to 2. But we should not take 1 and 2. The final answer is 0 to 1 union 1 to 2. 2 we should not take. Or I can write it as in the options 0 to 2. Here if I write open, 2 is anyhow excluded, 1 also we are excluding it. So this is, here we have a second option is correct. So coming to this question, 2x minus 1 by root function is defined 2x square plus 3x plus 1 must be greater than or equal to 0. So x into 2x plus 1 factors. So here I am using wavy method to answer this because many linear functions are involved. Here it is exact wavy curve I will not draw. Here it is minus half, minus 1, 0, half. What wavy curve says odd power is there. It crosses x-axis. And again at 0, it x is 0, it crosses x-axis because odd power. Minus of is there, it crosses x-axis. Minus 1, but this is not the exact graph because these are x is minus 1, it approaches 0. It kind of it approaches like this. But that doesn't matter for us here. This is enough to decide the boundaries. Uh, where it is positive means in this region it is positive, in this region it is positive, in this region. So x belongs to minus infinity to minus 1, minus of 0, union half to infinity. Right? This is our first domain. Now let us find the domain of the second function. Sine inverse log x to the base 2. Here there are three functions based on is defined for sine inverse log x2 must be greater than or equal to 0. Sine inverse range is from minus pi by 2 to pi by 2. So it is greater than 0 means it will be maximum value will be log x to the base 2. Maximum value will be pi by 2. Here it is uh, which implies log x to the base 2 should be greater than or equal to 0. Because and log x to the base 2 also must be less than or equal to 1. Last class we discussed its domain is minus 1 to 1. I cannot take minus 1 to 0. I am allowed to take only 0 to 1. Because sine inverse of negative will be negative. It can't be greater than 0. So here it is 0. I can write log 1 to the base 2 x greater than 1. Here it is 1. I can write log 2 to the base 2. So here it is between from these two I can say x is between 1 and 2. And log function is defined for positive values. So log x to the base 2 is defined for x greater than 0. So anyhow 1 2 is greater than 0, we don't have any problem. And another point here is uh, here less than pi by 2 means I cannot go up to sorry, sine inverse range yes minus pi by 2 to pi by 2. Yes, so root of negative is not defined. It is defined in between 0 to uh, pi by 2. It is okay. Basically, whatever it may be right hand side, it should be greater than for root to be defined. So final answer is 1 to 2. Right. So this is another good question. F of x has domain. Then he is asking domain of integral part of mod x like this. The function domain is this means integral part of mod of x must lie between -5 and 2. As I uh, here there are two parts. I already discussed it. It can be even 2.3, 2.3 also. More box of 2.3 is 2. You can go up to 3. That means here I can prefer up to 3. That means x lies between -3 and 3. I solved this part. The second part here is greater than -5 by 2. So modulus is there, it can't be negative. So I can say greater than 0. So greater than 0 means mod of x should be greater than 0. Instead of that, any x you take, mod x is positive, which I can say it is defined for all real numbers. Whatever real number you take, it is positive. Positive will be greater than -5 by 2. Right. So the final answer is it's -3 to 3, as well as it should be real number. So common part will be its real number. Common part is this 4,000. So in this problem, we have sin x plus cos x, which I can write sin x into 1 by root 2 plus into 2, root 2. Root 2 of sin of x, sin x cos 45, cos x sin 45. So root of sin x plus cos x, I can write it as root 2 sin of x plus pi by 4 is defined for sin x plus pi by 4 is greater than or equal to 0. Right. So if you solve it, we have one sort of x values, and the second function 7x minus x square minus x is defined for greater than or equal to 0. Less than or equal to 0, we get x minus 1, x minus 6. From here we can say 1 to 6. Now there are two functions, we have to take the intersection part. Here sin of uh, sin x graph basically like this. X plus pi by 4 means it shifts. At minus pi by 4 at 0, it will be 45. Again at 3 pi by 4, it will be 3 pi by 4 plus pi by 4, 0. The same graph up to this will be 2 pi by 4, where it is positive. Then you have negative 3 pi by 4 plus pi by 4 is pi. After pi, it enters into third quadrant, it will be negative, like this. Now we want it to be positive, and then that should be here 3 pi by 4. Another pi you take 7 pi by 4. So it will be 7 into 3, 21 by 4, 5 point. Still we can go for some more values because up to 6 we are allowed. 7 pi by 4 plus pi, it is 11 pi by 4. So this is the solution of this, and another part is 1 to 6. Where is one, is it before 3 pi by 4 or after 3 pi by 4 means? 3 pi by 4 is 3 into pi by 4 is 3.14 by 4. 9 by 4 is 2 point something. 1 will be somewhere here. Here it is up to 6, he says. It is 7 into 3, 21 by 4. Uh, that is 5.6 will be somewhere here. Now the common part where it should be greater than 0 and it should be a part of 1 6 and part of this. And 1 to 3 by pi by 4 also. After that 1 to 6 means this whole thing, but in this region it is negative, it should be positive. The common values must be 1 to 3 pi by 4, union 7 pi by 4 to 6. So this will be the domain of the function. Actually here tan function, to find the range of this, first thing should be where this is defined. X square minus pi square by 9. Once you multiply by minus, inequality changes. You get x plus pi by 3. That must be less than or equal to 0. So x should lie between this. Tan graph in minus pi by 3 to pi by 3. Tan 0, 0. Tan pi by 3 will be root 3. Tan minus pi by 3 will be minus root 3. So here tan function like this. So it is tan function is increasing in the interval minus pi by 3 to pi by 4. That means increasing means tan x is less than tan pi by 3, which is and here it is minus tan pi by 3. So where it is defined, those values only I am considering it. Tan 60 will be root 3. Here x in the sense root of pi by square by 9 minus x square. But into 3 is there. Oh, Here it is. Yes. So if you multiply with the minus root 3 tan root of pi square by 9 minus x square, but root x is defined in this region, but uh, pi square by 9, but we want not x, right? We want x square. It should be pi square by 9 because, and x square must be 1 minute. Pi square by 9 minus x square must be greater. Small 1 minute. Here you assume pi square by 9 minus x square as y. So that means y should be greater than 0 and y will be here other boundary. If you take root of pi square by 9 minus x square, it should be less than pi by 3. That means y lies between 0 and pi by 3. Tan y should be less than tan 0 and tan 60. If you multiply by 3, it's an increasing function, 3 root 3. So answer is 0 to 3 root. And this question here is, it is a root function, cos of sin x